Okay, as promised in class today, we'll talk a little bit more about how to name coordination compounds because there is some specific nomenclature rules that people generally follow when you want to describe it in text in a paper, for example. So here's kind of our general list. First rule, if you have, sometimes complexes can be charged. So if you have some sort of charged complex or it's an salt, right, you have type-charge balance, you typically name the cation before the anion. So you can have an anionic complex, put the cation first, like potassium, whatever, or you have a cationic complex, name the complex first, and then put the following anion at the end, chloride, sulfate, whatever it is. This is, this is familiar to you, so, right, we talked before about if you're talking about a salt, that's like a normal salt, not a complex, it's going to be something like sodium chloride, right? Sodium's a cation, chloride's the anion. Nothing crazy. Okay. Second one is when you have a complex ion, so you have your metal center as well as your ligands on it, so that's your complex ion. You name the ligands alphabetical and then metal. So name ligands alphabetically and then metal. So one example is in that Werner complex, we had, let's say, one neutral molecule. I don't know. I'm going to say something like this. NH3, NH3, NH3. So this you would name the amine ligands first. So this is ammonia, but then we'll talk about it later. But this is triamine, trichloro, cobalt 3. So ammonia ligand first, then chloro, A before C, then cobalt. Excuse me. Okay, if you have to name what the actual ligands are, so if you have an anionic ligand, then you call it whatever the prefix is, ends in O. So therefore, excuse me, chloro, it's a chloride, but it's actually, so then we have that O. Let's say if we have carbonate, it'd be carbonato. If you have a hydroxide ligand, it's hydroxo, et cetera, et cetera. Okay. Neutral ligands, generally you just put the name down. Use normal name. So triphenylphosphine ligand, you would call it triphenylphosphine, et cetera, except for some specific cases. So ammonia we've already seen is amine. Water is aqua. CO is carbonyl. Yeah, so those are kind of like the special ligands that have their own special names, which makes things confusing. Okay, yeah, so you already kind of done an example of that. Okay, so for the number of ligands, number of each ligand, use Greek prefix. So it's going to be di, tri, tetra, so 2, 3, 4, penta, hexa. So for this one, this example of the cobalt complex, we have 3 of each type of ligand, so it's triamine, trichloro, then cobalt. There is one except for, so if your ligand already has the Greek prefix in name, use bis, tris, tetrachus. Oops. So one example here, hopefully I don't run off the screen. So palladium with 4 triphenylphosphine ligands. So triphenylphosphine already has the prefix tri in the name of the ligand. So therefore, this is tetrakis triphenylphosphine. Phosphine, palladium, 0. Oops, that's a 0. Okay, and then as you've seen, what I'm doing is put the oxidation state of your complex in after the metal in in Roman numerals. Roman numerals in parentheses. Okay, and that's because in some cases it helps you determine the final charge. Okay, let's see. Okay, and then lastly, if your complex is an anion, if the complex is anionic overall, the whole name ends in the suffix 8. So, let me find some room. I'll do it up here. Okay, so one example is, suppose we have this salt. So tetraethylammonium. So this is not the complex, this is just the cation. And then we have, so zinc with 4 anionic chloride ligands. So overall, this is an anionic 2- charged complex. So this would be tetraethylammonium tetrachloro. Sorry, I'm just going to wrap over zinc 8. So because this complex is anionic, we have the 8. We have tetrachloro, and then tetraethylammonium. So I want to point out, so I didn't actually put the 2, so I could put zinc 2,8 in between the zinc and the 8. So zinc only has a 2+ oxidation state, so that's why for this complex we might not need to put that down. And then I also want to point out, so because you know the oxidation state on zinc, you know that this is overall a 2- anionic complex. So I didn't write that there are 2 tetraethylammonium cations, and the cations on there is just assumed, because you should already know the charge on the anionic complex. It's just like if we say calcium chloride, I don't say it's calcium dichloride because I know the positive charge on calcium is 2+. So be a little careful about if you're reading in the literature or you see this kind of name, be careful of charges so you know how many cations or how many anions to add. Okay, so we'll do some practice problems in class.